Alright, so for the first few problems, you're going to be finding the inverse and confirming your result, which means you're going to use composition, and restricting the domain whenever necessary. So for number 1, we don't have to restrict the domain because a cube function is 1-to-1, so it does have an inverse function. So let's go ahead and change f of x to y. 0.5 I'm going to write as half. So then I'm going to solve for x. So I'm going to multiply both sides by 2. So the 2 times the 1/2 cancels. And then now I have 2y equals x cubed. So now I take the cube root of both sides. And so now I have cube root of 2y equals x. Switch the x and the y. Cube root of 2x equals y. And then switch the y to f inverse. So I'll just put the f inverse on the left side. Equals cube root of 2y. So this is my inverse function right here. So now I'm going to test it. I'm going to do f of f inverse of x. So that means that I'm going to take the 1/2 x cubed, and instead of x, I'm going to put in cube root. Oops, I wrote y in, sorry, just realized I wrote a y in here. Should be 2x. I don't know why I did that. So 2x. And so I'm going to put cube root of 2x cubed. So order of operations tell us that first we're going to do the exponent before we multiply by a half. So we're going to take the cube root of 2x and raise it to the third power first. So when you do that, you get 1/2 times 2x. And then the 2 times 1/2 gives you x. So we do the other direction, f inverse of x. F inverse of f of x. Oops. And that's going to give us, we'll start with f inverse. So that's cube root of 2 times 1/2 x cubed, like that. So 2 times 1/2 is 1, so this is going to give us 1. And cube root of x cubed gives you x. So since both sides, both compositions gave us x, then this proves that our inverse is correct, so it's right. Alright, so same instructions as number 1. So first off, it's a cube function, so we don't have to restrict the domain. So we get y equals 3/4 x cubed minus 1/2. So we're going to add 1/2, because again, we're going to isolate the x. So we're going to add 1/2 first. Add 1/2. So the 1/2 minus 1/2, that's 0. Then I'm going to multiply by 4/3. So I have 4/3 times, I'll put the y first, equals 4/3. Okay, so this and this becomes 1. And so now I have x cubed equals this. So I'm going to take the cube root of both sides. So now I have cube root of, should I distribute it or leave it like that? Let me just distribute the 4. So I get 4y plus, let's see, right here I get, let me simplify first what's in the parentheses. So I get 4/3. Oops, it's still erasing, sorry. So it's 4/3 times, when this is y over 1, so then it's going to be, the common denominator is 2/2. So I get 2y plus 1 all over 2. So now I'm going to distribute, I can reduce the 4 and the 2, so 2 goes into 2 once, and 2 goes into 4 twice. So then we have, and it equals x. So now I have cube root of, I'm going to multiply across, so I get 4y plus 2 over 3 equals x. So you switch the x and the y. And then you just change the y to f inverse, or h inverse in this case. And there's the answer. So that's what we think the answer is. We're going to check it with composition. So h of h inverse of x. So we're going to take our 3/4 times, and then we're going to take our inverse, 4x plus 2 over 3, cube it, minus 1/2. Okay, so remember, order of operations tells us that we're going to do the cube first. We're going to take the cube root and raise it to the third power. And so we have 3/4 times 4x plus 2 over 3, because the radical is gone, minus 1/2. So the 3 over the 3 cancels, and so I have 4x plus 2 over 4, because I'm distributing the 4 here, minus 1/2. Well, minus 1/2 is the same thing as 2/4, correct? So now I could write it as a common, since they have the same denominator, I can combine them. So then that gives me 4x plus 2 minus 2 all over 4. The 2 minus 2 is gone. And then I have 4 over 4, which reduces to 1, so that gives me x. And now I do the other direction. H inverse of h of x. And that's going to be, and we just draw a line to separate it. A line to separate that. So I start off with the inverse, what I think the inverse is, which is this. 4 times, and in parentheses I'm going to put 3/4 x cubed minus 1/2 plus 2, it's all inside the radical, over 3, all inside the radical. Okay, so order operations tells me that I'm going to distribute the 4 in here and here, then I'll combine it with the 2, then I'll divide by 3 if possible. So when I multiply or distribute the 4 here with this one, I get, let's write the cube root first. The 4's cancel, so I have 3x cubed, and then 4 times negative 1/2 is negative 2, and then plus 2 all over 3. So 2 minus 2 is gone, 3 over 3 is gone, so I'm left with cube root of x cubed, so that gives me x. Since both sides, both compositions gave me x, then I know my answer is correct. Alright, number 5 is a quadratic. Now remember, this is a parabola with a vertex 0, negative 9. The k is negative 9, so the parabola went down 9 units. So this is not 1 to 1. This is not a, so I have to restrict the domain. So I'm going to pick the positive side, so I'm going to pick all x greater than or equal to 0. Because remember, this parabola, I'll just put it right here. Say this is negative 9 down here. This parabola opens up like this. So I'm only choosing the positive side, the right side. That's what this domain means. Okay, and that side, the pink part, that's 1 to 1. So y equals x squared minus 9. Again, remember, this is a domain, x is greater than or equal to 0. And I'm going to add 9 to both sides. So when I add 9 on the right side, I get just x squared. Then I take the square root. Normally it's plus or minus square root of y plus 9, but since we picked the positive side, then it's a positive root. So now we switch the x and the y, and then switch the notation. Okay, so this is the one that I think is the inverse, but I've got to verify it. So f of f inverse of x is going to be square root of x plus 9 squared minus 9. So this is going to give me, order operations tells me I do that part first, so x plus 9 minus 9, so that gives you x. Then I'm going to do the other direction, f inverse of f of x. And so I start off with the inverse function, so that's going to be this one. In place of the x, I'm going to put x squared minus 9 and plus 9. And so inside the radical, the 9 minus 9 is cancelled. So then I'm left with the square root of x squared, which is x. Both compositions give you x, so this is correct. Now for number 7, the square root function, we didn't talk about this in class so much, but I do want to just let you realize that we do have to restrict the domain because you cannot have negative numbers inside the square root. So the smallest number I can use for x is 5. Okay, why? Because 5 minus 5 here is 0, and 0 is the smallest number I could have in here. So I'm going to have to restrict my domain and say that x is greater than or equal to 5. Okay, so keep that in mind. So now we're going to do y equals square root of 1/4 x minus 5 minus 4. We're going to add 4 to both sides. Okay, so the 4 is gone because we added 4 to both sides. And now we got to get rid of the radical, so we're going to square both sides. And so on the left side I get y plus 4. On the right side I get 1/4 times the quantity of x minus 5. So I'm going to multiply both sides by 4. And remember, on the left side we have to use parentheses. So now I have 4y plus 16 equals x minus 5. Oops, I forgot the square, sorry. That's going to change it a little bit. So that's going to change this one, sorry, to keep it the way like this. Okay, like that. And so now I'm going to add 5 to both sides. So 4 times the quantity of y plus 4 squared plus 5 equals x. Now we switch the x and the y. Okay, we switch the x and the y, and we get 4 times the quantity of x plus 4 squared plus 5 equals y. And then write it in, oops, it's h, not f. So h inverse of x equals 4 times the quantity of x plus 4 squared plus 5. So this is what we think the answer is. We've got to check it with function, with composition. So it's going to be, I keep saying f, so used to writing f of x. So it's h of h inverse